So now, in this video, we have an op amp here. It's wired as a non-inverting comparator, but our signal is coming from a light-dependent resistor. So I'm going to quickly demonstrate this. If it gets dark enough, I lowered the lamp to the dimmest setting, then the output goes low. And, if it's any brighter than that point right there, now the lamp's at the highest setting, the output is going to be high. So normally, I use a trim pot to adjust our signal voltage, just because you can see me adjusting the voltage and stuff. You can't see the voltage being adjusted here at all. The only thing now you can see is that when I turn the lamp off, you can see the blue LED comes on, and when I turn the lamp on, the red LED comes on. But in any case, whenever I'm doing a demonstration with the changing voltage, that in a practical circuit will be something else that is changing the voltage based on whatever affects it, whatever makes it change it. So that's light falling on the light dependent resistor. When there's more light, then it gets a lower resistance and the voltage rises. Remember, these inputs don't let current in or out. And also, quickly I'll note, you notice that we got the inverting input down lower, the non-inverting up higher. On the physical component, the non-inverting is always lower, the inverting is always higher. So always pay close attention to that. You don't have to draw the inputs the same as they are on the physical component when it comes here. But plus does mean non-inverting, minus means inverting. So always pay close attention to that. And usually the schematics won't have the pins numbered like you see here. So in any case, I already demonstrated this circuit before, so not going to dwell on it too much. But it's an op amp right there, LM358. There's two on this integrated circuit. We're only using that one. And technically you shouldn't leave the one you're not using floating, but I haven't run into problems with it yet. So usually you make it a voltage follower with the input, the non-inverting input connected to ground is a good way to just kind of lock it in place. But I don't usually run into problems with it floating. I don't think I ever have. So in any case, yeah, we got an op amp right there. Comparator is the same symbol, but comparators usually have an open collector or maybe an open drain output. So the outputs don't work the same. Be aware that if you have a component that says it's a comparator, make sure you pay close attention what output it does. The op amp can sink or source current. So right now it's the source of current. We got the red LED right there. The 220 ohm resistor protecting it goes to ground. And, it's as close to 5 volts as it can. Red LEDs are not terribly bright at a given current. And so we want to try to give it, a fair amount. But again, the output doesn't get all the way to 5 volts. So, we're a little bit short on current there. Now I'm going to lower the lamp right there. And you can see we got the low output right there. So, again, it's comparing these two voltages right there. That's what the comparator circuitry does, even though we're using an op amp instead of a comparator integrated circuit. We got half of the supply voltage right there. So right now it's dark enough where we have more than 3,000 ohms of resistance right there. And so there's more resistance on the high side. That pulls the voltage down less than half of the supply voltage. And again, you don't have to do half or whatever. You can set this up all kinds of ways right there. I just try to pick the simplest way for my demonstration circuits to show the basic principles right there. So, in any case, we got half the supply voltage there. This is a lower than half right there. We don't know exactly what it is, but with this particular circuit, all we care about is if it's bright enough to set the output high or dim enough to set the output low. We can adjust sensitivity by adjusting that value resistor. So we got a low enough voltage to the non-inverting input, lower than that one, I should say, and therefore the output is low. So these op amps, the LM358, connect to ground better than the positive supply. It gives a better low output than a high output if you need to get close to the supply rail voltage. But it still will fall a little bit short due to the load. So the less load, the better. And yeah, 1000 ohm resistor, blue LED. There you can see it's plenty bright right there. And it's probably about 2 milliamps of current. This is not as accurate as a multimeter. And you also got to remember, whenever you're looking at the current of the power supply, there's other stuff that's consuming power. Current's flowing not just through the load, but to other places. So not much. You want to limit it the other stuff as much as possible with these circuits. So the inputs don't let current in or out. They just look at the voltage. If they did pass current in or out, then it would throw off the voltage. So there is a little bit of leakage. A little bit does slip through one way or the other. And so there's op amps with more impedance. Impedance means the opposition to current flow. Resistance is one form of impedance. And so they oppose current flow, some of them better than others. If you have a really weak signal, these are not terribly weak. They're 10K resistors, but like if you used million ohm resistors or something, this op amp might not be able to prevent enough leakage to throw that voltage off. Maybe you may need to use an op amp with more impedance. So, just be aware of that. But for this demonstration purpose, that's not a big deal. So again, these are all topics I covered quite a bit in other videos and stuff. But I really like the light dependent resistor for my changing voltage where we are not touching the circuit at all. I'm not turning a trim pot or anything. We could use the trim pot on either as a variable resistor to adjust sensitivity, or we could use a trim pot in place of these two resistors right there. Instead of doing half of the supply voltage, maybe 2/3 of the supply voltage, 1/3 of the supply voltage or something. That's ways we modify that, and I'm pretty sure I made a number of videos where I showed that, and I'll show them again because those videos don't get a lot of views, and so I just cover topics again when they don't get many views because they're all important. So in any case, yeah, I rambled on long enough. I think I covered everything, so we'll end it there. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.